Awesome. Welcome, everybody, and welcome everybody who's tuning in on the live stream on YouTube tonight. We are broadcasting on the Scottish Technology Club YouTube channel. So if you ever can't make it to one of the events, tune in there because we stream from both EdinburghJS and GlasgowJS. So that's something to look out for. Thanks for coming tonight, everyone. Congrats to the people who've got a job in the last couple of weeks. There's a few people in the audience. A little round of applause. You know who you are. It's really great to see people here get jobs in tech, and I'm really pleased for the people who are able to do that. It's been a bit of a struggle, I think, for people over the last few months / year. So it's really heartening that I hope things are picking up for people. Tonight, just before we kick off with the first speaker, I'd like to thank our sponsors, Fanduel, for hosting us, KPV Lab and 2i Testing for providing money for the catering, which I hope everybody enjoyed this evening, and to Scotland Is for sponsoring the live stream. So in terms of live streams, we are editing up the videos, and we will put nice kind of 4K edited, chopped up talks on the ScottishTechnology.club website. So that means you don't even need to go to YouTube. They'll be there edited without kind of all the crap you usually get on YouTube as well. So if you don't know about that site, go to ScottishTechnology.club. There's an email newsletter, and once we start posting those videos, I will let you know in the newsletter. It comes out every Monday whenever I wake up and hit the send button. Little announcement for next time. The next event will be on the 21st of May, and it's a community night. So that means rather than like technical talks or whatever, we'll have people just doing 5 minutes on kind of like a side project or a showcase, like their portfolio or whatever. So if you have something that you're desperate to talk about, or even not quite desperate to talk about, but maybe you've got something you find cool or interesting to do with JavaScript or the web, let me know. Are there slots for that? I'd be happy to accommodate anybody who wants to speak. Please do speak. We've had little community talks before, and it's just nice to know who's in the audience. It doesn't need to be totally in depth. It's just, you know, something we can all share together. So on that note, Daniel's going to talk about TypeScript, search, AI. Thank you very much. Daniel, take it away.
Hey everyone, I hope you can hear me okay. I'm not supposed to be sitting, but I'm doing some live coding, so that's what's happening. So yeah, like Jamie said, I'll be talking about TypeScript U and AI search. This is a bit of an interesting talk, I hope. But before we get in, a little bit more about me. I'm Daniel Phiri. You can find me anywhere online as Malgamvis. I do developer experience at Weaviate. I'm a writer, developer, artist, plant dad, and Greg's fan. I love the vegan pies, as I was bonding with Jamie over. So yeah, anyway, just like quick poll, who's used or knows what TypeScript is? Nice, pretty much everyone. Same. And who has used or knows what vector search is? Okay, hopefully we can get more hands at the end of the presentation. I also know what it is. So some backstory, I've been building these like AI-enabled applications for the web, because when you talk to a lot of people doing AI-adjacent things, it's mostly in Python. And I'm like, the web can do some stuff also. And so I've been building these projects, which I share online, I share on my Twitter. And so in doing that, I sort of got this job at Weaviate, which is a vector database. And I mostly do a lot of projects on the web in JavaScript / TypeScript. And so I got into this company to sort of craft the developer experience for what their TypeScript client is like. And so it introduced me to this whole new world of search. Like, we never know like how search is around us. And so I'm just going to be sharing my journey building that stuff. Okay, so I won't ask you what your search experience is usually like. I'm going to show you what most of our search applications look like. And so I have an application here built with, built with Next.js. And so it's a keyword search demo, because that's how a lot of our search works. And so I have a couple songs. I'll just go to VS Code and show you what those songs are. And if I go to keyword, and I'll just like make this a bit smaller. Is this visible? Yeah. OK. So basically here I have like some data. I have songs, a song title, artist, album, and year. So this is just stuff that I got from Pitchfork. So let's pretend this is really important information, right? And I'm just going to put my search results once I search them. And what our search experiences usually look like is this, right? We have filter, and then we have we basically have a filter that filters out any result that isn't the keyword that we're searching for, right? And so if I go back to this portion and type, I know there's a song here called Respect because I tested it before. It says Respect by Aretha Franklin, right? If I search the Beach Boys, I basically get back the Beach Boys, right? If I search beach, right? This is, we don't even get it back. Let's see. Nope. That's because we're searching over title and not artist. And so basically a lot of search is trying and failing and then trying to adjust to what your data looks like. And then you end up, banging your head. Let's try and add some data here and see what else we could do. So we'll just copy this. What's a really popular Scottish song? You could just scream it out. Otherwise, I'm going to say Summer by Calvin Harris. Right? He is Scottish, right? Okay. We could have kept it. Anyway, so basically I'll search summer, and I'll add sun basically to this. And so when I search summer, because I'm searching over title, I should get back Calvin Harris. Anyway, that's the search experience, right? We're matching keywords. And this tends to be a problem. Why? Because when we want to get things that are outside the context but related, we sort of don't get those things back. And why is that important? Why do we want to get stuff that we're searching for? It's because search is literally how we've evolved as humans. We search for information, we search for meaning, a bit too much. We search for a lot of things, but basically everything we do on the internet in real life is information retrieval, looking for what's relevant, and then processing that information, right? So our songs, our movies, our shopping, our Wikipedia, all search, all information, all stuff that we're getting together. And so it really sucks when we're looking for something and we can't really get exactly what we want, as I just described, right? And so that's the problem. Sometimes search is this. And so like I mentioned, I think filter is something that we can relate to. We're basically matching keywords, right? We're looking for a specific piece of text. We're looking at our data and seeing what is in that. Is that piece of text in that text? If it is, let's present it, right? And it's the same as this. When we ask the question, why do airplanes fly? This is the keyword match, right? Technically, this is a good result with keyword search, but is it relevant to our question? Not at all. And basically, it's just a really terrible experience. And so I want to introduce the idea of keyword search, and I'll get to the client and the TypeScript stuff in a bit. So the idea of keyword search is you sort of want to get the semantic meaning of what you're actually searching for. And so when I search, why do airplanes fly? This answer has no keyword match, but is relevant and answers my question. And so this is what a semantic search experience looks like. Let's see if we can build that. That's my goal. We're going to build this with TypeScript with the new client that we just developed. And hopefully I can explain some of the things that led us there. But basically, at the end of the talk, hopefully this is you. But before we get into actually building it, I just want to share a bit about the science behind keyword, because it's very vague to say you want to capture the semantics or the meaning of data and then be able to search through that. And I just want to make that a bit easier. Has anyone heard of the phrase vector embeddings? Okay. So if you have, or if you're curious, or if you don't know what vector embeddings are, it's an array of numbers that sort of encapsulate the meaning of something. And so when we have data, as we have in this example, it could be text. We pass that through a machine learning model, and that model creates a representation of what that data represents, and then represents it as an array of numbers. And these are vector embeddings in a nutshell. And so going back to our example on why do airplanes fly, which is a very valid question, we have a couple of data, or sort of like data, we have a couple of answers that we put into our machine learning model, and we get that representation. So we get our vector embeddings. We have another one, which is the actual answer. We put that into a machine learning model, and we get our embeddings. And so what we do is we get all these vector embeddings and then plot them in our space. And just to like help visualize this, I have this. And so the idea of a vector space is everything that's sort of similar is grouped together. And so here you could see we have a cat, we have a dog, we have a wolf, we have a chicken. And so all similar items are sort of grouped together. Same thing here, apples, bananas. And this is just like a three-dimensional representation, by the way. Actual vector embeddings have like hundreds of thousands of dimensions, but just to help you understand that. And I think something that might resonate a bit more in terms of encapsulating meaning is RGB, the color coding system, red, green, blue. And so RGB is just the scale of how much red, green, and blue is in a color, and then colors, right? Okay, so vector search. What actually happens when we do search something? We type in why do airplanes fly? That goes into a machine learning model, and then we get our vector embeddings for the query. We then plot our vector embeddings in our vector space, and then we do a really interesting thing where I like to think of this in vector embedding as an entity, and it sort of looks around it and it says, who's closest to me? And basically, because of the way vectors work and vector search, we use an algorithm called approximate nearest neighbors, and it sort of looks around it, and basically what's around it is similar to it, right? And so we embed the meaning of why do airplanes fly. Around it should possibly be the answers of why airplanes fly, and then that's what gets returned to our users. And so in a nutshell, this is the AI search. A really interesting thing about vector embeddings is we can extend that from just text, and we can get the meaning or semantics of images, of videos, of audio. And I have a really cool demo that I built with Nuxt.js. And so yeah, basically, you can search through images and text. Sort of like this. I have this demo. I think you get the idea. So it's multimodal search, data with multimodalities. You index it and put it in your vector space, and you can search through it anyway. I won't be talking about how to exactly build that, but I'll be talking about the core of that in the implementation of the library. And behind all of that, like I mentioned, is this company that I joined, Weaviate, the AI native vector database. And what it does is it stores these vector embeddings. We have a lot of deployment options. We're open source on an MIT license, and we have Docker, Kubernetes, deployment options. We have the AWS Marketplace. We have our own cloud service. And we have a couple of different language clients. And very importantly, Typescript, JavaScript, which I'll be talking about today, which is what I'll be building the project with. So we have this goal in mind, right? We sort of have an idea of why keyword search isn't necessarily the best thing that we could use. We know how semantic search encapsulates the meaning of our data and helps us search over it. And now I just want to go through what a workflow looks like. You have your data, right? But how do I actually benefit from using something like semantic search? And so a big part of that is importing your data. Whatever objects you have in whatever form, you put that through your application and then send it to the vector database. The vector database uses machine learning models. I did talk about these machine learning models. They're called embedding models. And it says, hey, I have this data. Could you create vector embeddings for it? And then the machine learning model sends those vector embeddings back to your vector database, and it stores them. And then you can query, like we were querying. So how do planes fly? When we type that in our search application, that sends that query to the vector database. The vector database tells the machine learning model, hey, remember that data that you made embeddings for? Could you make an embedding of this also? It sends it back, and then it sends you the response. And so we're going to attempt to go through that. Yeah? How does that sound? Not excited. OK. No, I'm not expecting claps. It's OK. Basically, before I get into that, we have a lot of machine learning models that we support. OpenAI, Cohere, Hugging Face, Mistral. Basically, if you want to add your own, also, we support that through Hugging Face. So it's pretty much you own your data, you can have it, it's yours. And we let you pick what you want to do with it. Right, so let's do a demo. And so, like I mentioned, we're going to attempt to build this pipeline. And I'll show you how the client works. And so I have a Typescript script here. And because I don't have that much time, I put some of this stuff. And so we have our normal import here. We're importing Weaviate, which is the Weaviate object which we use to initialize a connection to our cloud service. You could do this locally, of course. But I don't want to spin up Docker. I just add a bunch of credentials, my API key, my OpenAI API key, which I'm using to create those vector embeddings. I did mention that you have that choice. And so the first thing we want to do is create a collection. And so collections are the way we interact with Weaviate. When you think about traditional databases, a lot of our interactions are with tables and then rows and columns. So imagine a collection as a table. And so we'll define a new collection by saying const new collection is equal to await client. And so this is sort of the first part of the client that we've added. A big benefit of TypeScript is the IntelliSense that you get. And I think everyone sort of being new, does anyone use Weaviate? Great, so yeah, okay, nice. There's a new client.
I thought you said VBA. Oh, sorry.
No, Weaviate. Don't worry. So no one uses it. But basically the idea is you're getting into this client and IntelliSense sort of helps you have an idea of what you want to do. From what I said, we want to create a new collection, right? And so we go client dot, we want to interact with collections, and we want to create a collection. And then from doing this, we already know what the arguments look like and we know what it's looking for. And so we have to provide config, we'll provide a name. We can call this, I have music data that I'm going to add into my database. So let's just go with Calvin Harris because I liked Calvin Harris. And so importantly, so we have a collection name to interact with. We need to vectorize our data in one way, right? And so we choose a vectorizer, and we say weaviate.configure because we have options to configure what we want to use. We have a vectorizer here, and we get the choice of the text. Yeah, I'm glad that you're liking that. Text to vec OpenAI. And so we pick that as our vectorizer. And then because I want to sort of wow everyone at the end, I want to do some generative stuff. And so I'll pick a generative module to actually generate some stuff. And so it's pretty much the same workflow. We have weaviate.configure.generative. And we'll stick with OpenAI, not Azure, OpenAI. Oop. Right, OK. So that's the first part. We've created our collection that we can interact with. Now we need to import data into this collection. I'll just uncomment this. This is some JSON that I have, and I'm using Axios to pull that. And then once we have that data, we can import it by saying const data added. I'm sorry, I'm on the spot coming up with names, so they're not the best. This is async also, so we'll say await. Really importantly, before we do that, so the way we changed one really important thing about the way we interact with Weaviate. Before, it wasn't really straightforward to interact with collections. And so we have this that says we can define what collections we want to interact with by saying my collection is equal to client dot collection dot get. And so we said our collection name was Calvin Harris. And so you can see there we have some really nice IDE prompts and help. Right, so we have Calvin Harris. And so now what we need to do is use this my collection object that we're using to interact with Calvin Harris and say await my collection dot. And then here you can see what do we want to do? We want to insert data. And so we have a very nice function here, helper method, that is insert many. And we'll put in tracks.data. And then once we've done this, we want to make a query just to make sure that we have the data actually added. But we'll just like console log this. Oop, that's not supposed to happen. Right, data added. And then let's try and fetch some objects and see what happens. And so we'll say const fetched objects is equal to, so again, if we want to interact with our database, it's through the collection. And we'll say my collection dot query dot fetch objects, and just fetch a bunch of objects. But let's limit this. And so this is another thing that we did. You know, have you ever used like a method and you're like, what arguments does it take? What can I do with this? Super intuitively, we just have that show up for you. And I'm like, why don't I use TypeScript more? So, OK, we'll run this pretty soon and get to actually building the query application. And just print out fetched objects. So we know this is fetched objects. Let's say, hello, we did this. OK, so this is the import, the part where we import the data. I'll just run this really quickly. It's a lot of songs, so. OK. Oh, forgot to await that. But basically, it's there. Let's just comment this out so we don't. We have to uncomment that. So we basically just want to get back the objects. And we should say fetched objects dot objects, just so we can actually see what data we're working with. OK, so we have all these songs that are appearing in our database. But this is just like fetching everything. There's no vector search happening. Let's actually do some vector search. And so we'll go into our next application. Next, sorry. And so I have a page here called vector.view. And so if you're not familiar with the way Next works, this is just sort of a section where we can write our JavaScript. And I'm utilizing something that I really like about Next here. I have an API that I've built basically that will handle my interactions with Weaviate. And so all of this is in new search. And so what we want to do here is query, basically. And so just to go over this, we import the client. I'm using Zod for schema validation because what I'm doing is I'm sending a GET request to this API, and I need to make sure that that's like the right stuff is happening, and I'm actually validating that. And so I just have an event handler here that checks if everything is fine, if the query is OK, and once that's validated, I can then run operations. And then, again, collection first approach. We want to actually make a query. We'll say const query, or just like response. Let's use response, very easy, very basic. And so our collection, my collection is equal to, where's our client? Dot collections dot get. What did we call collection? Calvin Harris, right? OK, very easy to remember. Cool. Right, so now we interact with our collection, or query. And so now this is where we use our vector search. So we say near text because it sort of looks around it using text. You can also use images to search inside, like I mentioned. And so we'll pass in our query. And so because one thing I like about this is it understands the context. And so I'll just, my search query will be search term, actually. I shouldn't make this complicated. Cool. And then let's like limit this to five objects. And then I'll just uncomment this. And so basically, when I go to my application, I should be able to make queries. But before we do that, we have to actually make this work. And so const search result is what we receive, basically. And cheat code, I'm using generics here, which Weaviate lets you use. We also just added generic support. And so if I go to my types.json here, I have track search results, and I have this sort of like this type that I'm adding to the generate object, basically, which makes sure everything's super type safe here. And so I should actually import that first. So import type. No, actually, let's not use the type first, and let's just see how annoying it is, right? Just so like the point resonates. Right, when we click a button, we submit our search, we get a response, and then we want that to appear on our screen. I'll get rid of this because we don't need it yet. And basically, at this point in development, you're like, right, what objects do I have? Or what objects am I getting returned, right? I have to go back and check. And be like, okay, I have title, I have artist, I have album. What do I want to display? I guess I want to say title. And let's see, by artist. And it's super, it can be super annoying, but it's just like one file check. Let's try this. Let's just navigate to vector. And so, let's see. I'm sorry, Scotland's in my head, so I'll say songs about Scotland. So how are we doing here? Anything relevant? He's Scottish? There we go. Okay. So you could say stuff like songs about infidelity and let's see, you see, like it gets that. And it's super interesting that works like that. But just to sort of like go back to this like generic thing that I mentioned, we have all our types here. And this use case is just, not there, sorry. This use case is very specific to querying, but I think like what I like about this is it extends itself to a lot of the operations that you want to do when you're handling and dealing with a lot of data in like a search context. You want to make sure that when you have a sort of pipeline working, you write a script, you write a function, you write an API sort of route, it should work as it's supposed to. Or if it doesn't, it should tell you why it's not working. And so this is why we added this support for generics, which work really well with Nuxt also. And so I'll just import this type, which is called track search result from types, and then add that here just so that, one, if we try and make a query for anything that's not in our type, we get an error. And two, when we're typing stuff, we also know exactly what is in our object. So track search result. And so like I showed before, as I was typing something here, like if I want to work with result, now I have an idea of the fact that I could just do that. And it works really well. And like I mentioned, it works here for making queries, but you could do the same thing with collections. You want to make sure you're getting the right collection or interacting with like the right collection. You can have generics for practically everything. And I think this is extremely valuable. Right, okay, I did mention I want to wow you, and I think I'm almost running out of time. So let's do like a generative query. The big thing that really wows people about AI is being able to interact with LLMs, right? And I think this is a really interesting use case. Yeah, you have the power of vector search, you're able to get the context and sort of deal with unstructured data in a really efficient way. But can you extend that and have interactions with large language models? Absolutely. How do you do that? Let's try and see. So we'll go back to our file here where we have our server. And what we'll do now is just change this names to the generate namespace and run a near text, and then pass in a prompt as the second argument rather. And we want to pass in a single prompt. And what do we say? What do we want to ask OpenAI? I don't know, this usually works in like non-English speaking countries because I'll be like, let's do this in whatever language you speak, but this is all English, so let's do it in French. Give me a tip about song. Not song, actually. What is that? It's title. Title by artist in French. I should maybe type this better. Give me a fun fact. A quick fun fact. Okay, basically, so now I don't know why that's complaining. Now we should add this because we kind of need it. And let's search for, I don't know, pies or food or Greg's. Okay. I don't know why we got this back. But as a somewhat French speaker, I can verify that that's actual French. And right, and so basically you could change what queries or prompts you send to your large language model. And you could also group all of this. So basically, I could say grouped task and say, out of all of these, tell me your favorite song. Let's see if the LLM has character or taste. What is your favorite? Do I know how to spell? No. Anyway, where is that? So bad at navigating VS Code. And that should work. Okay. Let's just refresh. And let me actually make a proper song, just like songs about Africa. Oh no, I didn't put it in the right place. Oops. Because it's one result. I'll just put it there. It's not happy. What? Oh, there's no results. Never mind. Yeah, I didn't plan for this use case. It will scream, but it should work. Or not? Okay, let's try love. Huh. That is not supposed to happen. I see. I'm doing something I'm not supposed to be doing. So basically, in my server, I'm returning objects when I should be returning generated. And so if I say, let's just console log this so I can end quickly. But lessons learned. Response dot generated. That's not working. I didn't do Typescript well enough. It's not helping me. Oops. Okay, wrong file. Yeah, there we go. Okay, I was in the wrong file. Right, let's try this again. About love. Okay, where's our terminal? Oh, that's weird. Oops. Okay, my favorite song out of these would be Layla by Derek and The Dominoes from the album Layla and Other Assorted Love Songs. Okay, some wrangling there, but clearly it works. Anyway, so this is what I wanted to sort of like share, the experience of like exploring this new search, this sort of like new way of searching, and doing all of this with TypeScript, or rather leveraging TypeScript. And that's basically it. If you found this interesting, you can check out some resources for how to like build that multimodal app that I shared. Yeah, that's been me. I hope you found this useful. Thank you very much. And if you have any feedback, let us know.
I always find it interesting when watching people live code and seeing how people was like, oh, hang on, what's happening here? And the kind of thought process that goes on for debugging stuff. So cool, always great to see. Does anybody have any questions about this, about AI search, TypeScript, live coding? I mean, I think it's very useful to learn about. So yeah, I guess, like, how did you get into this? I mean, is this something that you've picked up from working at Weaviate, or is it something that you knew before?
Yeah, absolutely. It sort of fell in my lap. But like I mentioned, I was doing a lot of AI application building before, just like indie hacking, and the idea of vector embeddings sort of came to me. And so I made that relation. And then when I joined the company, I realized how important search is in interacting with our vector embeddings. And then just like getting into building and crafting the developer experience of a TypeScript client was also really interesting, where like I just find it amazing that you could do some of those things out of the box with a client, sort of like in this first time I'm using it sort of feel. But yeah, that was my introduction and experience with it.
Is there something that, if someone is new to this, like the concepts, like sort of a news source or something like that, you'd recommend people check out, or do you tweet about it, or? Because I know you've done a lot of videos, because you sent me the list.
Yeah, occasionally I tweet about it. I think there's like generally just like build stuff if you like to build stuff, and yeah, like GitHub I guess is a good place. Kaggle also, if you're looking for interesting data sets to play around with, just like look at that, mess around with it, build some scripts, build some apps, and yeah, hopefully I can share some stuff. I'll get back into doing it. Like a lot of my time has been taken up by like making sure that this is functioning the way it's supposed to function, and now I'll be building more applications. So.
Awesome. So if anybody, can you go back to the QR code? So if anybody builds stuff, please do send me a message, because I'd love to feature, like in follow-up, kind of newsletters and stuff that people built for their kind of own blogs or websites or whatever, experimenting, and I'd love to share it back. Cool. So yeah, you should all take a little snap of that. Right. Cool. Thank you very much. Another round of applause. So you're from Paris, which leads me on to the next thing what I'm going to say, which is .js Paris have given us a discount code to their conference, which is in June, which Alan is currently attempting to put up on the screen behind me. Thank you. Maybe, we'll see. Anyway, so if you want to go to .js Paris and take 10% off, use that code there. They have also given us a free ticket to give away, and that free ticket I will raffle to people who fill out a form, which Alan will put the QR code up for now. I will post the link to this form in the Scottish Technology Club Discord as well, but if you want to enter that competition, this is a draw for a ticket to the conference, not flights and accommodation in Paris. But yeah, it's worth like several €100. So if you're interested in going to Paris and going to that conference, then please do sign up for the raffle. It's been shared with GlasgowJS, and you can count the number of people in this room, count the number of people with phones out, calculate your chances. Looking good. So yeah, .js Paris, good stuff. We're going to take a 5-minute break now, so if you want to go and grab some more refreshments, then be back in here for 5 minutes for Kimberly's talk. Thank you, everybody. Cheers. Okay. Cool. Okay. Welcome back, everybody. Alan is just trying to follow me around with the camera. So welcome back, everybody, on YouTube. All good? Cool. Right. Alan wanted to say something. So he's going to finish pressing buttons.
James really worried because it was his birthday yesterday, so he thinks I'm going to get everyone to sing happy birthday. But he would absolutely hate that, so we're not going to do that. However, there was something I wanted to say, was I was live streaming EdinburghJS pre-COVID, so that's like 6 years ago now, 7 years ago. And there's nothing on the previous organizer or anything like that, but I think it's fair to say in terms of the community, in terms of the numbers that we're getting in, the fact that we got Edinburgh and Glasgow kind of quite connected, I think, and people coming across from both cities, which is super cool. I think it's fair to say that this has sort of surpassed, what we've had before, and a huge amount of that is just down to this guy here, Jamie, and all of the hard work he's put into this. So I just wanted to give a big thanks to Jamie. For he's a jolly good fellow, for he's a jolly good fellow, for he's a jolly good fellow. And so say all of us, and so say all of us. Okay, right, we'll leave it there.
Thank you. Yes, I've broken my holiday, my birthday holiday, to come back and do this, because I love it so much. Yes, and that was very stressful. Thank you, Alan. Cool. So now for the second talk, which I'm really looking forward to. Kimberly is going to be talking about a brief history of the web. Take it away, Kimberly.
And I am going to try to keep it brief. I've actually set my timer. Hi, I'm Kimberly. I'm a software engineering manager here at Fanduel. This year, 2024, is the 30th anniversary of the very first website I ever launched. So I've been doing this for a little bit. It seems like yesterday I started. So just a little timeline here to help orient us. I'm going to be, not doing that way, going this way. Going back in time, the animation on the screen here is not great, I know, sorry about that. But context is everything, so we are talking about Chrome. Everybody familiar with Chrome, right? Everybody's used Chrome here, right? We're before Chrome. We're talking about Firefox. Folks familiar with yes, all right, thank you, you're my people. Pre-Firefox, Safari, we're going back before Safari ever existed, right? Going back before Internet Explorer, and was that anybody's first browser? Hey, what a groundbreaking browser, IE3 for Mac, one of the first complete CSS implementations ever, so let's not diss it. I have friends who worked on that browser. Netscape. Netscape, anybody's first? Well, who was your first, right? And then, anybody remember Mosaic? Mosaic, so that may have been some people's first browser, even going back before that. Most importantly, perhaps, though, I used to call this a brief history of the web for modern developers, and the context being, it's also before this thing, the iPhone. So we're going back before that ever existed, just for some context. So. That little timeline will be at the bottom of the screen to orient you as to when in time we are. So we're going back to 1989, and we are going physically to, I wish, CERN. So we're just outside of Geneva, Switzerland. Why are we at CERN? This is where the web was created. People get confused, the internet, the web, right? So internet, America, web, CERN. So great, finally Americans can't take credit for something. I say that being American, by the way. And we're at CERN, and just for your context, the reason why I talk about this so much is because I've had the privilege of going to CERN, not once, but twice, to do research on the history of the web. So I'm just gonna be literally spouting facts and fun little anecdotes at you. There's no big story arc here. I'm not here to tell you about the evils of modern development or how we've deviated from the original vision of the web or anything like that, although I may make little comments here and there, but please ignore me. This is really just history for the fun of history. And then you can inquire about whatever you want at the end. So most people know this guy, Tim Berners-Lee. He's the inventor of the web. Everybody knows Tim. Sir Tim, excuse me. So he was working at CERN. He'd actually been there in the 70s, left for a little bit, went back in the 80s. In the 70s, he had created this database that was running on his own personal computer. And it was sort of his idea about how to keep track of information over large data sets. But when he left CERN in the early 80s, they literally just dumped his computer, wiped the hard drive or whatever. And so when he came back in the 80s, all of that information was gone. But he had this idea. So CERN, lots of researchers come to CERN, do all this research, obviously. Physicists come to CERN, do all this research, and then they were walking away with their data sets. And then new researchers would come and then do other experiments. And everybody was constantly shifting their data around. There was no one common sort of set of data, or it was really hard to get access to because they were across different platforms. So he was like, let's create one sort of system where all of this information can live. And this is sort of where these wheels get turned and how can you keep track of all this information. Now, Sir Tim was not alone. He did not just as one man come up with this idea, go, hey, here it is, World Wide Web, it's a great thing, everybody should use it. His partner in crime is this man, Robert Cailloux. So I've had the pleasure of meeting Robert. So if Tim is the father of the web, I would call Robert either the godfather or the fairy godfather even. Everybody needs sort of that helping hand, that person who's behind helping. And a lot of comments really that I'll be sharing are Robert's perspective on the invention of the web. So his name's going to come up quite a bit. He's Belgian, working at CERN, and both of them are basically working in the IT department. They're computer programmers helping to write software that the physicists and researchers are using in their experiments. So there's actually quite a large IT department at CERN, a really big data center now. It's pretty cool. So these two folks and a proposal, which I'm also wearing on my t-shirt for anybody who's like, what is on your shirt? It is this, the original proposal for the web, written in March of 1989. So this is where Tim is starting to put down his thoughts on how information could be put together and managed in a system, right, where data is going in, it can be retrieved through sort of a search mechanism. He's got this diagram, and he sends it off to his manager. This is a very short proposal, by the way, 2.5, 3 pages, basically. He sends it off to his manager, this man named Mike Sendall, and what do you think? And Mike writes on the very top, vague but exciting. It says on the back of my shirt, vague but exciting. And then on the back of it, so you actually, I've held this in my hand, I'm not kidding. You turn it over and on the back he's written, I like the browsing style this should make possible, intuitively right, and potentially user-friendly, but it could be frustrating. How do we know we can get it right? And that is kind of the clincher, right? They had no idea they could get it right. This all could have gone terribly wrong, but, well, we're all here. So clearly something went right. Now, Sir Tim's ideas were not just plucked out of thin air. They were built up on a history of thinking about information systems. One of sort of the earliest futurists in the space is a man named Vannevar Bush, who in 1945 wrote a paper called As We May Think. So this is all about how man-made machines will one day think, or at least the idea that information will be cataloged and somehow searchable, digestible by machines, easy for people then to refer to. Ted Nelson, who is known as the father of hypertext, in the 1960s, he was creating a system called Project Xanadu. So he was actually the person who even coined the term hypertext. Officially in 1965 was the paper that he wrote about that. 1988, actually the year before the World Wide Web, this paper was even written, there were other people here in the UK working on a system. And there's Dame Wendy Hall. Gosh, I almost said Harris, wrong name. Wendy Hall. So she was writing a system called Microcosm at the time, which is another sort of hypertext-based system. So lots of stuff going on in the space. The web was not the only thing. And in fact, at the time, 1989, there are lots of other systems that are available on the internet. So again, this is a good way to remember the difference between the web and the internet. There were lots of other systems that you could almost call competitors, or at least other systems that people were using to directly communicate with one another. And some of these we still use today. So FTP, obviously, we can still use quite a bit in order to exchange files. IRC, well, that's now pretty much your WhatsApp or your Slack or what have you. But some of us still literally live on IRC, which, cool. We don't have to get into handles or anything like that right now. We can talk later. Telnet, which, of course, SSH supplanted that. But some of these other systems like Gopher and Waze were really far more popular at the time that the web first came out. And in some cases for good reason, but they eventually did things like charge fees, or they were based on services that charged fees. Big difference with the web. They didn't charge anything, and we'll talk about that. So there were other things. People were getting online. It's not like that was brand new, but the web itself was quite distinguished. So Tim gets his funding. He gets basically what he's asking for is money to go get a computer. And the computer that he got was a Next computer. So, Steve Jobs, yay, big success. But actually, he failed at Apple. He was kicked out of his own company, right? And then he went and he started Next Computer, a company that only sold 5,000 computers total. And then he kind of failed there, but then somehow got back into Apple. Very confusing. And those computers, they were like $10,000 each at the time, right? Pretty expensive machines. But Tim wanted to get one of those so that he could write his prototype. I'm calling it proof of concept or prototype. He did not use that term, of course. And this was this was literally, I'm saying proof of concept, but it was fully functional, right? It's a browser, it's an editor. He wrote a server. This was really kind of your all-in-one idea of this is like future vision. This is what the web could be one day. Now, here's the cool thing. One of those times I went to CERN, we made a simulator of this. So we'll just go over and have a quick look at that. So if you go to this website, which is worldwideweb.cern.ch, you can learn all about the history of the web. We've written a whole bunch of stuff. I spent a lot of time looking at the original source code for that version of the browser, kind of wrote some stuff about it. But then we also built this cool little, interactive, this is cool, right? We're literally using the web to rebuild the original web browser. So it's kind of fun. And it most of the time works. It is a little bit funky. CERN has changed some of their security policies on their network, so it sometimes blocks certain requests. And of course, I took off my glasses. But I think if we go to document and then, does anybody see open from document reference? Document, that one, maybe? Yep. Hopefully, let's see if this will work. HTTP. Which it may or may not. Haha, not found. Well, but anyway, that's what it would look like. Hey, not found. So you can go have a play with this. But we literally spent a lot of time on an old Nextcube, experimenting with how it worked. Just getting it connected to a live network was a pain. Anybody who wants to talk about old token ring networks connecting to a modern day gigabit Ethernet connection, a lot of fun there. But yeah, we basically recreated this just by playing around with that. And we had to create our own font, too. That was the other fun thing. Sorry, nerding out. Let me get back to the talk. So that was first. That's 1990, right? A year after he writes that proposal. He gets the money. This is actually like mid-1990. So December of 1990, he's sending out a message saying, hey, this project exists. I'm going to be putting it out into the world. Watch out. Now, what are the three things? There are three really important inventions that Sir Tim had to make in order to get this thing going. Most people can guess them, but we're just going to go through them in case. So first of all, HTML. So HTML was technically a new language, although it borrows significantly from SGML, which is a standard generalized markup language, which was already in use at CERN. So people there were pretty familiar with it. But there were some serious deviations between them and the earliest browsers. The types of tags or elements that they looked for kind of deviated. And if you read any of those websites, you'll see some stuff that we've written up about those differences. So you need a language to convey all of that information. The second thing that he had to come up with was a protocol for that network transmission, right? So HTTP is an application layer protocol, so it's running on top of your network. But that original thing that he created was really just HTTP GET. There was nothing else there. Really, really basic. And then thirdly, and this is perhaps the big key, which most people don't think about as necessarily being an invention, but at the time it was, and still is, the URL. Right? So just the idea that you could connect a server address with a file path, smush those things together, and then of course it has the protocol out in front. And one of the things that Robert likes to talk about is the fact that the 2 slashes was technically a mistake. They didn't realize they needed both of them. So it could have been, all this time we could have just been typing HTTP:/ instead of 2 slashes. But oh well, you know. Hindsight's 20/20. But these are the 3 brand new things that we didn't have before. And we don't, you guys don't need to see that, sorry. Oh, it loves to tell me when I'm not on the right network. So there we go, 3 key inventions, important stuff that we take for granted every single day now, but at the time, big, big deal. So great, he's got this proof of concept. It can run at maximum on 50,000 computers. Not a great idea. We need some way of getting this idea widespread, right? So what does he go and do? There we go. Well, let's create a minimum viable product, right? So we went and we did big picture, proof of concept. Here's what we can do. Now let's bring it down and like really break it down to the most basic level. Let's write something in C that can compile on any operating system. It's just going to be plain boring text, but it's going to work for a heck of a lot more users. And this, personally, was my first experience to the web. It might have been for a lot of other people. This browser was literally created in a hallway. So that picture of me at the beginning with that sign that said where the web was born, that plaque is in a hallway. And in fact, this was written in a hallway outside of Tim's office. The student, it was a student, in fact, who wrote it. Her name was Nicola Pello. She was one of the very few women involved in the early web. And she was actually a UK math student who was there on a summer assignment. So maybe you didn't know that before. Now you do. And again, this is another project I got to go over to CERN and work on. So you can hop over here. Oh, not that one. This one, line mode browser. You could take a look at that. And if you want to see the original website, so yeah, I mean, look at this. This is like the original, this is the very first web page. I'm going to talk about it in a second. But it still renders in a modern browser. How much code did you write 30 plus years ago that you could say would actually still run on a modern device? Yeah, like, I was writing code 30 years ago. I could take out my Commodore 64 and still run that code on that thing, not on a modern thing. If, so you go here, and if you want to launch the line mode browser, you can do that. And we, again, tried to make it look and feel very much like being on an old IBM PC, to the point where, and I don't know if this will work, but if you start to type, no, it does, it makes clicky sounds. It's supposed to make clicky sounds, come on. It just may not. Anyway. If you're on your own computer, it may do that. Again, sometimes it works, sometimes it doesn't with the network protocols. You can also use it to load modern day websites. So this is actually loading code that we built into it. No. Yeah, no, that's loading the code that we built into it, but you can also launch it in a mode that will let you load basically as a proxy. I'm running this off of my local machine, so this should in fact work. And I love to use 2 different examples. So first, let's try Google. Right? So, oh, wait, it just crashed. Sorry. Computer must have gone to sleep. Oh, did it need? Thank you, because I don't have my glasses on. Put on your glasses so then you can see. There we go. What the heck is this, right? So for compression purposes, Google's just throwing all of their JavaScript, all their CSS, everything inline in the page, which, again, literally having looked at every line of the code for the original line mode browser, this is what that browser would have done with this file. Because it would have gone, I don't recognize some of these tags. Oh, but whatever's inside of it, I'll just spit out onto the screen. So not great. But if you take a modern website written not so much with this particular use in mind, but like if your CSS is being pulled in via an external file, your JavaScript gets pulled in via an external reference, here's what can then happen. I'm going to use my own website. Oh, look at that. It's just content. Yay. This is nothing special, right? This is, hey. The whole file is like maybe 30 lines of code anyway, because there's nothing for it. I've literally taken most of my information offline, but that little bit is useful. And yes, if you look at the source code, there is a CSS file. It's just an external file. So when the browser comes across it and goes, style, I don't know what that is, and it throws it out, it's throwing out the external reference too. So basically, this is just a little node server that intercepts all of the network requests, edits the HTML before it then has it rendered. That's all it's doing. But it's showing you what an old original browser would have looked like. And if you do compile, and it's actually not too difficult to compile the original line mode browser for a modern day machine, you can then still use it to surf. There are updated versions that understand HTTP 1 and 1.1, 1.2, not 2, but you can still find some servers out there that will still send back a response, and you'll get something like this. All right, so again, getting back to things. So minimum viable product, this gets out there, and now we start to get some traction, right? So announcements are starting to get out. People are like, hey, what's this cool thing? Oh, I had mentioned the first website, so here it is. The code, I mean, this is Sir Tim's code, so you can't criticize it too much, right? It's his. It looks, it looks kind of familiar. You're also kind of looking at it going, what? So there are familiar things like, I don't know, I think I'm too close to the screen. So header, title, header, right? So header, in that case, is what became head today. Header, of course, now for us is an HTML5 element, but title still exists. Body, H1. Of course, we've got all of the anchors all over the place as links, but then there are these names, and the characters refer to, in some cases, there were these document references by ID numbers, which was sort of a next thing. Actually, they were called next ID anyway. So there were bits that sort of tied into the original next source code that are a bit archaic. But this site went online August 6th of 1991. And it's still online, so you can still go to info.cern.ch and have a look at it. And that's what it looks like rendered in that old browser. OK, now, what made the web finally take over? What you just saw, not entirely impressive on its own. Most people were just sort of like, oh, interesting research project moving along. The big differentiator is what happened in April of 1993, so 31 years ago almost today, or as of next week. CERN composes this document, and a lot of this was actually at Robert's urging. It was sort of like, let's get this thing out there. CERN shouldn't have any responsibility for this, but also CERN was sort of like, ooh, if this thing takes off, we don't want to have any we don't want people coming after us, because who knows what this could possibly do. They write this very simple 2-page document. I've also held this in my hand. Robert has the only copy. CERN has lost theirs. I am not kidding. He keeps it in like a big metal suitcase, and he what do you call it? Attaches it to his wrist. Yeah, he handcuffs himself to it, so it literally, like when he takes it out. But I've gotten to hold this, piece of paper, and so yeah, this is it. This is literally when CERN gave the web to the world. Open source wasn't a term at that time, but this is really basically the first truly open source software. CERN is putting the following into the public domain. So the client, the server, and all of the common code. They relinquish all intellectual property rights to this code, both source and binary form. Permission is granted for anyone to use, duplicate, modify, and redistribute it. It could have been released under BSD, right? BSD was a license form that existed at the time. It cost about 100 francs, about $20 to file for that. They didn't want to pay it. Yeah, we don't want to pay that $20, $30. Now we're just going to send it out into the world. But hey, then that's why we're all here. I mean, come on, that should get a round of applause, right? Total accident, and yet here we all are today. Built an entire industry. So Robert, one of my favorite things he says, and he says it pretty often if you ever get the chance to meet him, the web being simple and forgiving has led to its enormous growth. I would also argue, and free. I think anybody who's worked on the web long enough kind of knows sometimes free is really important to getting your product to take off. And I think that definitely had a big part to do here too. But it is simple and forgiving. Number of known web servers, just for context. So we were talking about, can I get this? Please, please. I can't. April 1993 is kind of in the middle there. So the very first web server goes online August 1991, right? That's basically Sir Tim's server. There are 2 online before the end of 1991, probably the rest of CERN. You get about 50 by the end of 1992. And then, that things blow up. The paperwork gets signed. August 1993, you've got about 200 servers online. These are just people who are running servers and basically sending Tim email going, hey, we've put something up, just FYI, in case you want to add it to your list of all these web servers. And then you go, basically a year ahead, and now you're at 1,500. And somewhere in that 200 to 1,500, my first server went online. Yes. Get to say I was early at something. So. But let's talk about that forgiving part. So then Tim realizes, all right, this thing's gone live. I need to really shepherd it because it's going to die otherwise. So W3C is founded. He leaves CERN. Robert's kind of still at CERN, but helping out. Basically, we need to keep this thing going and figure out what's going to happen. We need to get people involved with it. Anybody ever been involved with the W3C? No, it's seriously like herding cats, but we can talk about that another time. One of the big responsibilities that they have is to start putting together some standards for the language, because basically as soon as that paperwork got signed and Mosaic came out, Mark Andreessen, he's like, no, I have this idea, we should put images. We should put images in web pages. Let's do that. And Sir Tim's like, no. And he's just like, nope, we're going to do that. Then we're going to do this next thing. We're going to starts coming up with ideas left and right. People are just going in all directions. So he's like, we need to consolidate and start creating standards. So HTML, there's no version number associated with what first came out with those early browsers. But let's just say there's HTML in 1990. So Tim is like, let's just let the browser do as much as it possibly can. And Robert, serious computer scientist, is like, no. Strict interpretation. If there's bad HTML, nothing should load. Right? So, okay, Sir Tim obviously won out here. Although if you looked at some early browsers, right, Netscape, if you gave it a table and didn't close your table or anything correctly, no table. You just didn't, your page stopped rendering. Internet Explorer, hey, this is the thing, right? Microsoft here got it right. Let's just try to do the best that we can. Let's just try to figure out what they meant. Let's be accepting. So be conservative in what you do, liberal in what you accept. This way, definitely won out. W3C starts off with, let's start HTML at version 2. Sounds good. All right, so that gets us 1995, so a year after W3C gets started. Then they're like, ooh, we should think about how to style websites. That probably, doing all this BG color and text color stuff, maybe we should find a different way. There are these 2 grad students working in different places in Europe. They're brought together. Let's try to work on one single spec. Cascading style sheets get started, version 1, 1996. Meanwhile, HTML still being iterated on. Don't ask me why, but the next version we get is HTML 3.2. Sure, why not? And then meanwhile, CSS is still being iterated on, so then we get CSS2. Cool. And then we keep iterating a bit on HTML, and then we get HTML 4.01. And people who know these version numbers know how specific they are, know about, especially with HTML4, what do we get? We get strict, we get transitional, and we get frames. It's just chaos at that point. So then there's a whole other conversation that starts up, which is we're missing a language here. Right? So as Robert will tell you, nature abhors a vacuum. And Tim was just like, no, we're done. HTML, CSS, declarative languages. Anything else should be done on the server. And then Robert's going, you need some kind of imperative programming language on this thing. People are going to want to do stuff on the browser. Look how slow the connection times are, right? This is still the age of dial-up. And even if you were in a network-based setting, those networks were not fast networks. So, very divisive. But what happens here, right? Mark Andreessen drops in. He's like, hey, I got an idea. I'm going to put together this thing. Originally had a different name, but I'm going to pair up with the good folks over at Sun. We're going to call this thing JavaScript. Confuse the world. Java, JavaScript. Everybody will understand the difference, right? And then he puts that into Netscape. So now we've got all sorts of pandemonium happening. JavaScript goes off, becomes regulated under first IETF, then ECMA. W3C is like, we don't want anything to do with this. But they're also like, well, we're good. We've got HTML 4.01. We're going to move into this thing now called XML and ditch HTML, which, OK. Well, no, we won't come back to that. We're just going to leave that there. And then CSS2.
I love XML.
And then CSS, meanwhile, CSS2, there's pandemonium here because Netscape and Microsoft basically have totally different implementations. Oh, there's my 30-minute. I'm almost done. But hopefully this is interesting and people don't mind me just continuing to ramble on. So we've got real problems in CSS2, which, by the way, don't get resolved until 2011. And then HTML, of course. XML basically dies a horrible death. They try to do XHTML. It just, people are yelling and screaming at each other. Literally, browser makers are screaming at each other. Of course, Bill Gates is like, I'm not going to do any more of this. And then he gets strong-armed back into it. But and then you get a bunch of people who are like, screw the W3C. We're going to go start our own group. And then they finally come up with HTML5. So huge gap in there. And the only reason that those things eventually happened is because Safari, Firefox, and Chrome came out. Because in order to get a final version of CSS, they had to have 2 matching implementations of CSS, which means you needed more modern browsers that were actually being worked on in live time to keep iterating to finally agree on how things should work. What a pain in the behind. So modern standards are really only about 10 years old. Of course, we've got all sorts of CSS3, 4 modules. Fortunately, they were like, let's break it up. Let's not try to make it one massive document any longer. HTML, now supposedly a living standard. But most people just consider to think of it as just one thing. That's great. It's a new age of the web. Sometimes I like to talk about it's really important to iterate early on in the life cycle of something. Maybe that is good, maybe it's not now. I don't know anymore. It's been too long, I'm too old, I can't think about it. So there you go. Any questions, anything at all?
Thanks, that's great. I really love hearing about the history of this. And I think one of the key lessons is that, even back in the early web, from the get-go, you could just make your own stuff, and you can still do that. And I think that's a great thing about our jobs, is that you can just put something online, make it yourself, and you don't have to ask anyone permission. So, yeah. Does anybody have any questions about history of the web? Not you, because you're going to ask about XML. John, can you take the mic from Victoria? Sorry, just.
Thank you. I thought that was really good. I'm thinking about the It's like, what was it? The guy who invented the Spectrum never thought it was meant for gaming, and Tim Berners-Lee never thought the World Wide Web should have pictures or look pretty or anything like that. And it should be about learning, and it should be about connecting information, all that sort of thing. And to that extent, I'm wondering, do you think something like Obsidian is kind of closer to what Berners-Lee had in his head when he was thinking of the World Wide Web and of HTML in terms of what it would look like, what it would do, and what it would be useful for? Obsidian it's like a knowledge management thing that works entirely with Markdown documents and plugins. So and it's reinvented the hyperlink in that with Markdown documents you can kind of link to Markdown files inside the same collection from another using a double square bracket. So you just say this is the link to this links to this links to this. And that's all it does, or it's that's all it's imagined to do. It's just designed to help people connect ideas by saying what's really important. Here's a load of text, and here are things that it connects to. Is that broadly what he was kind of thinking about?
It could be. I've only met the man once, and really just to shake his hand, and that was it. So I can't say. I mean, he's written loads about what his thinking was at the time, and probably where that is now is a bit different. I think he's actually started 2 different companies. Like one was very much focused on that, like OWL, the whole idea of ontological, is that the right word? Ontological search, so like, yeah, and that would probably align a bit more with that idea. But I'm sure he's also, he can't be entirely displeased with where things have gotten to, I would assume. But some of those other systems, like the one that I mentioned, Microcosm by Wendy Hall, that was also spun off into its own business. So a lot of those types of systems, I think, were purchased by really big companies that were doing sort of just straight up information management. Yeah.
They kind of saw it. This is about information. It's not about cats, so it's not about.
It's not about cats, but now where would we be?
Yeah, exactly. Cool.
The farms, honestly, the pharmacological industry should be scared because we could literally all heal ourselves through cat videos. I am not a doctor.
Question from Alan. Curious me, I'm not on XML.
A little disappointed you bring up XML style sheets, but I'm not going to ask about that. You probably know the answer to this then. I don't have too many problems with the / and HTTP, but who was the bright spark that used the longest letter in the English alphabet and then thought we need that 3 times in a row?
That is a great question.
Rather than just web or just W?
So that very first browser, the thing that was built for the next computer, was called World Wide Web. And as Robert tells it, he and Tim were literally just sitting around going, what should we call this thing? And one of them, nobody wants to claim credit for this, said, well, let's just call it World Wide Web, or how about World Wide Web? And they said, yeah, we can always change it. So here we are, and in fact, this little, I put this picture here specifically because Robert told me a cute little anecdote about it. So he made this logo, they said World Wide Web. They were going to this hypertext conference in Texas. They literally had to pack up the next computer and take it with them to Texas in order to demo, again, the system, because they couldn't guarantee that there'd be a Nextcube for them to run it on, or that they'd even be able to get it running on that machine when they got there. So they brought the computer with them. They made these little pins that were the W, and they're in green like that because Robert has, oh crap, I'm gonna forget the word. What is it when you hear, like when you hear sounds? Synesthesia, thank you. So he sees the letter, or he sees the color green when he hears the letter W. So that's why it's green. That's why I made this green. If you can see the green. If you can't, I apologize.
Thank you very much for the talk. So let's say you are elected dictator of the World Wide Web Consortium, ruler of all the browser vendors. What do you change?
This is the JavaScript Meetup, and I am part of the anti-JavaScript JavaScript Club. No, actually, so JavaScript, What do I change? Trying to answer your question directly. What do I change? I don't know that I really want to change anything. I mean, you want diversity. You want sort of diverging ideas and opinions to influence where something's going. You know, and look, at this point, you can compile a browser on pretty much anything, including your toaster. Probably could compile one onto this clicker if I wanted to. But it's the #1 computing platform, right? JavaScript is now the most popular programming language in the entire world, and you can teach it to like 3-year-old kids. I mean, like what is better than that? I don't know. I just. Yeah, what would you change?
Cheers.
Kind of answered the question already, but what do you think in the future could or should happen now that the browser is practically an operating system in itself as well?
I think I should retire and let other people figure that out. I mean, look, I'm still writing CSS 2.1, so nobody wants my opinion. I'm just happy to see what other people do with it to keep innovating the platform, keep it going. Launch it into space, you know. Create Voyager 3 and send that out and let it keep talking to it. See if it keeps talking to us in 40 years.
You said you created a font for the first browser?
Yeah, well, actually, for both of those websites,
Okay.
we created our own fonts in order to make it look like the original machines that we were working on. So yeah, the team, it was like 14 of us who worked together on those projects, and we actually had a font designer on the team who like sat there and painstakingly recreated the exact font and then compiled that into the right.
Can anyone use it?
Yeah.
What's it called?
It'll say on the website.
Okay.
Like I think we actually called them like IBM something something something, and the other one was probably called Next something.
Okay. Thanks.
Yeah.
Picking up web design tips from Cool. Anybody else got a question?
I think he has a question.
I wondered if you could talk a little bit more about how you said the web has diverged from the original principles of what it was intended for, and if you had any thoughts about, like, as I understand, the Web3 movement is intended to sort of let users like take back control to some degree, but I don't know if it's sort of all hype, all filler no killer. If like you had any sort of expert opinions on that.
See, when people say Web3 to me, I think about the design movement that was called Web3, which was like around 2006, 2007. That was Web3. Now this new Web3 is like a whole nother thing, and I'm not really sure that has anything to do with web. It's just technology-based, and it might communicate over HTTP, but I'm not really sure what else. And I'm saying this totally admitting, like, yes, I studied computer science and everything else, but most of this modern stuff I do not follow because it just sounds like money-making scheme to me.
Yeah, that was sort of low-key what I was asking.
Yeah, okay. Also, I do really, I mean, I think also the older I get, the more concerned I am about the planet. And it's like, we're literally killing the planet in order to cool servers. And then when somebody says to me, well, let's go launch them and put them on the moon, I'm like, no. Let's stop destroying things just for the sake of technology. There's got to be a better way. So maybe we need to divest our resources from building websites to finding more ecologically friendly ways of building technology. Maybe that means morphing more into some sort of biotechnology, which then presents a whole nother set of issues. And also, I've read plenty of science fiction, so I know that's a bad idea in our hands anyway. So I don't know. I have no answers. I just like to talk about this kind of stuff.
If in the name of eco-friendliness you could take one big website off the internet, the drop of a hat, which would it be?
YouTube. I mean, that's the one that would have most impact, right? I mean, and I also say this because, so I mean, this is, so think about the age of blogs and RSS, which has sadly gone by, killed off, thanks to Google largely, right? And Google buys YouTube, and then they start encouraging people to put videos online. And videos are a great way of documenting the human experience, for sure. There's more video content now created and put online every second than like the entire, like the amount of data ever produced ever in history. So like, it's cool because you are capturing this, but at the same time, is all of that is it all real? Like, are we really capturing the things that we want for posterity to be? I don't know. I don't have the answers, but I think YouTube is also brainwashing people. And anyway, I'll stop. Sorry, I keep going off into my own thing. They're rage typing, punching their screens. Sorry.
I really appreciated your talk. It was great. And one of the things I liked was the sort of view of Sir Tim and Robert and some key actors in there, because they definitely maybe are placed in a sort of hallowed position when maybe they were not necessarily standing for all the things that we imagine they were.
Yeah.
Now, following up, I guess, a bit on Victoria's question, have you spent a lot of time thinking about Web 5, Sir Tim's latest project, aiming to put people's information back in their own hands, sort of giving them pods which they can carry around to different sites? I'm sure you're all familiar with this, but just...
I read the initial press release, and that was it. I was like, okay, great, thanks. It sounded a bit like Microsoft actually had an initiative like that 20 years? I forget now how long ago it was, but it was a while back. And they were talking about something similar, and there was like one person who was recording every aspect of their daily life and like storing it, I guess, ostensibly to a drive that they were carrying around, but then it was being backed up to the cloud with this idea that their whole life would be infinitely searchable and every moment at their fingertips type thing, and that they'd be able to take it around and use it for different purposes. That's all I knew.
On that, I mean, there are a couple of startups at the moment that do that for your computer, you know. Sort of recording every moment of your screen and making it searchable, which is, I don't know, slightly terrifying.
Yeah. Yeah, it is. It is.
Cool. On that terrifying note.
Shut it all down. Turn
Thank
it
you
all
to Kimberly.
off.
Can everybody give Kimberly another round of applause? Thank you. So thank you again to Fanduel, KPV Lab, 2i Testing, and Scotland Is for the sponsorship for this evening. Without their support, we wouldn't be able to have essentially a free event that people can come and learn from. So really appreciated for the sponsors on that. Community night next month on the 21st. I really want people to come forward for this. The community nights are as good as we make it. So if you've got something you want to share, or if you're like, is this a good idea? Just message me and I will help you figure it out. There's going to be a few first-time speakers, I'm sure, in both Glasgow and Edinburgh. So you'll be in good company, even if you're a little bit nervous about speaking. So on that note, we're going to finish up, and please do join us after in the pub along the road, which is the Fountain Bridge Fox. And I always look for James for some reason. Just check that I've got the pub name right. I am right. Yes, thumbs up. Good, cool. Thanks very much, everybody, and I will see you next month. Cheers.
Yep.